Hey everyone, this is GlacierCTF hosted by Los-ifier from Austria. Overall pretty fun CTF. Lots of good challenges, some easy, some definitely a little bit harder. For this video, I'll be covering the intro challenges, the 3 web challenges, and 2 of the pwn challenges. At the end, I have a little demo of a website I'm starting to build. It's called ctfwriteups.org. It's a way to share CTFs and easily find all the writeups for CTF instead of having to search the Discord. If that's something you're interested in, the demo will be at the very end. But anyways, let's get started. The first challenge is Skilift by mole99. There's some text, but basically we're going to be given a command prompt and we need to type in a password. And if we type in the correct password, we get the flag. The password is checked by this .v script, which is Verilog. Verilog is a hardware descriptor language. You can use it to design digital circuits. And this is what it looks like. This module thing, this is basically a function. It's going to accept this input and output a lock. Basically just like a Boolean variable if we succeeded or not. It's going to define some temporary variables. They're called registers in Verilog. So we have all these, and then it's going to go through a series of stages and perform operations on the key that we supply it. And at the very end, it's going to check if the end result is equal to this. And if this is true, we pass. So pretty much a very simple key checker. What we can do is we can copy all this out, put it into its own Python file, and we just start from the end and we work backwards. So the very last step was checking if the temp4 variable was equal to this. So we just set temp4 equal to that. Temp4 was calculated from temp3, which was just subtraction, so we're just going to do the addition. And then from here, we're doing a little XOR, reversible, so we're also going to do XOR. Just make sure you use the right byte order. It's going to compare the first byte and the first byte here, so make sure you use byte order big. Then it's shifting left here for stage 2 and 1. So we're going to shift right, and technically it's a rotate. So we're going to rotate right, temp2 by 5, and specify 64 bits so it knows how to do that rotation, and we're using pwn tools for that. And then the last stage, or the very first stage, was doing this AND with F0, F0, F0. So it's only taking the high nibble from every byte. But that means that basically it just means in your key, only the high nibbles matter. The low nibbles don't really matter at all. They can be anything because they're going to be ANDed out or masked out. So you can just ignore them, or you can just skip this step too because it doesn't really matter. Then we print out the key that we were able to generate, and we connect to the remote server, we give it the key, and we spawn an interactive. So if we run it, python3 solve.py, it's connecting. Here's the Skilift. Please enter your key. We sent it the key. The key we sent was this one right here, and we get out a flag. It says Glacier Verilog isn't so hard after all. Fun. The next challenge is RSA. It says, I heard that RSA with multiple primes is more secure. My n is very large, so there should not be a problem. We're given an output.text and a challenge.py. So in this challenge, they're going to generate a large n, but that large n is going to be constructed from a whole bunch of small primes. And so we can see it's 4i in range number, so it's 256 primes, but each prime, when it does get prime, is only 24 bits in length. So this n is easily factorable, and if you can factor n, that kind of takes away the entire security of the protocol of RSA. So we can do this, and then after that, it's just standard textbook RSA. It's going to take the flag, raise it to the power of e, so 65,000 in this case with the n, and then print out the values. So basically, we just need to factor n, calculate the totient so that we can calculate d, the decryption key, and we win. So you can go through and try to factor n and calculate the totient. Since there's some repeated primes, it makes it a little bit tricky calculating the totient. Thankfully, we don't have to figure that stuff out. Sage is amazing and it does it for us. So you can do Euler-phi, which will just calculate our totient for us in Sage. Hit enter, and here it is. So we have the totient. The totient thing, if you don't remember, normally you do like maybe phi is equal to, it's like p minus 1, q minus 1. This is what happens when you have like just a p and a q. But if it gets larger, I don't quite remember how it works. If all the primes are unique, you can just do something like this. But when you have repeated ones, I think you have to do like s and r. I forget exactly how it works. But we'll just have Sage do it for us so we don't have to worry about it. So we print out the totient. Once we have the totient, at that point we can just do textbook RSA. So we're going to calculate d. It's just the inverse of e to the power of the totient, or sorry, modded the totient. So we get the decryption key, and then we're going to decrypt the ciphertext to get the plaintext, and we do a long to bytes, and that was it. So let's exit out of this. Python3 solve.py. Here we go. GCTF. Maybe I should have used bigger primes. And yeah, fun challenge. The next challenge is Los-ifier. It says normal binary for normal people. The authors are Paideia Dilemma and Huxis. We're given a netcat port and a download file. So for this challenge, we're given a binary called shall. It accepts some input and it prints some stuff out. To solve this, we're going to be exploiting a buffer overflow, and then from the buffer overflow, we're going to be wrapping to a system bin shell. So not too bad of a challenge, but the actual exploitation point is a little bit different. If we look at the main function in Ghidra, we can see it's defining a buffer here, 256 bytes. It's going to do some setup. It's going to read into that buffer, 256 bytes. It's going to do a printf and then return 0. So nothing really looks wrong with this. But one thing that's strange is when we printed out high, or we said high, it then said los high. And we don't really see a los here on the printf. So we know something wonky is going off. And that's because if we go into the setup function, they're defining a custom register printf specifier. So OX73 is S. So instead of using the default %S, they're going to be using this printf handler. And this is where the bug actually is. So the goal of this challenge was to exploit the buffer overflow in this challenge in this custom printf handler. And then from there, we can wrap in get shell. The actual bug occurs because we saw that the buffer input size was 256 bytes. But in here, they're going to do some copying to add that los string to the front. But they only allocate a buffer of like 50 bytes, OX 50 bytes instead of 256 bytes. So we have very easy buffer overflow. It's easy to get kind of tricked up on this buffer overflow. Like if you clobber it, like this fwrite doesn't work well and you'll get a bunch of libc errors and stuff like that. The easy way to bypass this is just send in a bunch of null bytes. Because it's going to do the string length, and if you send in a bunch of null bytes, the string length is only going to be like 3, so it's only going to write like 3 bytes to this fwrite thing, and everything should be much easier. But yeah, that was pretty much it. We're going to do a buffer overflow, maybe 50, I think it was 50 OX55. One thing that's a little bit weird is the buffer overflow is slightly offset because it's copying that los keyword, and then it's going to copy our payload at the end of the los keyword, so it's not like at an even offset. It's -3. Then after that, thankfully libc was linked into the binary. So we have the known, everything is already there. We don't need a libc leak. And also pi was disabled, position independent executable. So we know the address of everything. So somewhere in here, there's a system call, system, and it is at a known address, 404 AEO. And it will always be at this known address, which is nice. Since libc is also in there, there's also the string bin shell somewhere in here. So we just need to do wrapping. I'm not going to talk too much about wrapping. There's plenty of resources online, but we're going to wrap. We're going to pop an RDI, the bin shell string, and then we're going to jump to the system, and we win. And that was pretty much the whole challenge. To see what the solve script looks like, this is just standard pwn tool sort of stuff. We're setting up the context and everything. We're going to connect to the remote host. This is our wrap payload. So we're going to do pwn.wrap on the elf. We have to do some stack alignment stuff. I'll talk about this in a second. So this is about stack alignment. And then this is the actual payload. So we're going to search the elf binary for the bin shell string, and it's going to return the address to us. And then we're going to call system on that. And so wrap tools or pwn tools, the wrap stuff is just amazing. It does the pop RDI for us to set the register correctly before we call system. And then it'll find the address of system and jump to that. So then we just send in we have to figure out how many bytes to send it. In this case, it ended up being OX55, which makes sense. Like if you kind of look at it, it's called printf handler, I think, printf handler. We can see this is 1, 2, 3, 4, 5, and then there's going to be the RBP. So it should be 58, but we have to subtract 3 for the los, so 55. Another way to actually get this though is I calculated that value kind of at the start. I think I subtracted the wrong way, but to determine if you're doing it correctly, you can do pdg attach p, and you can just send in a value that's easily recognizable, like pwn.p64 ox deadbeef, and we'll connect locally and just see what you get. So let's load this up. We need tmux python 3 solve. Finish. Actually, let me change the size a little bit. Hopefully that's a little bit visible. But if we continue, something should happen wrong, and we can see our RRP is at deadbeef. That means it tried to jump to deadbeef. But if you were off by a byte, like let's say 54 or something like that, and we run it again, RIP will be dead B. So we can see we're missing the EF, which is just probably down on the stack a little bit. So you just add 1 to 55. And you can do this to kind of quickly guess where the correct, or how many bytes you're supposed to write. But just a quick little tip to figuring that out. But anyways, we have the ROP chain. We know everything's working correctly. So we'll send it and should be good. Like I said, we had to do this. Actually, I'll show what it looks like when you don't do it. Let me go back. You're going to run into some stack alignment issue. Cool. So we ran into an issue in do system. So we were able to jump into system. If we look at RSI here, we can see a bin shell. So we're probably able to pop the registers correctly, but for some reason we're failing on this instruction. And this move APS XMMM word, this is a 16-bit instruction, which means it expects things to be aligned. And so that means RSP, when it does that, this RSP plus 50, RSP basically needs to end in a 0, and it's not ending in a 0, and so this instruction gets mad. So to fix that, if you add an extra return statement somewhere, all it's going to do is it's just going to push the stack down by 8 bytes. Nothing actually happens. It just returns to the next line. And so that way the RSP will end in a 0. So that's what stack alignment's about. So we just find a random return statement somewhere. We add that to our payload, so that way the stack is aligned correctly. And now everything should work. So we're going to connect to the remote, send in our raw payload. Let's see if this works. And ls, and we win. So we can cat out the flag, and we get it. It says, "Los speak uwu, love you." So fun. The next challenge is my first website. I just created my first website. You can even do some calculations. Don't forget to check out my other projects. This is by Kroxios. Sorry. And we're given a URL. No source code, unfortunately. But anyways, we can see my simple calculator written in Bootstrap. We can do some numbers. We can try some server-side template injections or like maybe some eval errors. We don't get anything. And also the thing said, check out my other projects. What's weird is if you go to check out my other projects, there's nothing here. So at first it almost seemed like we're supposed to do a dir buster. So I went and checked the rules and they said absolutely no dir busting. So I guess we're not supposed to be doing a dir busting. But then I remembered we had this exact same challenge in a different CTF maybe a month ago. I don't remember what CTF it was, but we can see we have this reflected content right here. And so what you can do is you can try seeing if it's something interesting, like a server-side template injection. And it is. We did 1 + 1, and we get 2 here. So we just have a basic server-side template injection. Like I said, this was a challenge a couple months ago. I forget what challenge it was, though. So cool. We have server-side template injection, so you can go to Hacktricks, find your favorite payload. I think I have one saved already. You can try config just to make sure it's working and you know which one it is. I just assumed it was a Python one. And we can see, cool, we get a whole bunch of cookies or a whole bunch of environment variables. So we just have a very standard Jinja template injection. Cool. From there, like I said, just go to Hacktricks. You can download any of the server-side template injection payloads. I found this one. This is the one I normally use. So we have config, class, fum, envar, globals, import string, os, popen, and then cat out the flag. You can, in here, you can do a bunch of like ls and stuff first. So let's ls root, see what we get. We can see app bin dev etc and then flag.txt. And then from there, you just copy out the flag or cat out the flag and you get it. The page you're looking for at GCTF 404 flag was found, doesn't exist. So there's our flag. So fun. The next challenge is Glacier Exchange. It says we have launched a new revolutionary exchange tool allowing you to trade on the market and hang out with your rich friends in the Glacier Club. Only billionaires can get through. Can you help me hang out with Elon Musk? The authors are Writeups and XSS Kevin. We're given a website and a download file. To go to the website, pretty simple web app. We find out that this is just a fun display, just sugar. Here we have our balances. Normally this starts out with a balance of 1,000 and these are all zeros, but I've already done a couple exchanges. There's a button here to join the club. It says we don't have enough money to join the club, and this is how we exchange money. So if we wanted to exchange 10, for example, the conversions are always 1 to 1. We click convert. We can see this went down by 10 and this went up by 10. So that's the entire web app. If we look at the source code, there's 2 interesting things. There's a function for in the Glacier Club. This is what we want. If we can get this to return true, it'll give us the flag somewhere in here. Yeah, if you are in the club, it'll give you the flag. So we need this to be true. And this is true when the balance of the cash out is greater than 1 billion and everything else is equal to 0. So we want this to be greater. We want this to be greater than 1 billion and everything else to be equal to 0. The other interesting API call is the transaction where we can convert from coin to coin. For when we do this, we give it a JSON payload. It needs a source coin, a target coin, and a balance. There's not much validation that is done. The only validation that really occurs is the source coin and the destination coin have to be valid coins, and the amount has to be greater than your current balance. So there's 2 tricks here that we can employ. First, source and destination can be the same coin. It doesn't validate that they're different coins, which seems a little bit strange. Like, why would you want to do that? But it is useful. The second one, it's not really validating balances. Yes. It's not validating balances in any way, so we can supply negative numbers, and it's also casting that string to a float, which allows us to do some more trickery. But yeah, abusing this function, we can get the Glacier Club check to be true. That happens from two little things. First is, so we normally have a balance of 1000. If we subtract a balance of float minus infinity, we get infinite. So that's our first trick, is we're going to supply values of minus infinity. And the second trick is we're going to supply the same destination and source coin. The problem is if we were to do like cash out, if we were to add minus infinity to make this infinity, we would be subtracting infinity from one of these and it would not be equal to 0. And it's hard to go from infinity back to a 0 using only addition and subtraction. So the trick is the other float value, which is not a number. Not a number. Not a number, at some point it's going to be compared against, you know, a billion or something like that, and this will always be false, which is the other thing we want. And so to get not a number, what we can do is, or what just happens, thankfully, is it's going to do, if we specify the same coin, it's first going to subtract minus infinity, and then it's going to add infinity. And what happens is, add minus infinity, is we're going to get not a number. And like I said, we already saw that this check passes, and so we're going to have over a billion coins because it's not a number and the check just passes, and everything else will be equal to 0, so we win. So the trick was just to pass minus infinity for both the source and destination coin as the balance, and then the same source and destination coin. To see what this looks like, solve. I'm using Python request. Here's the URL, starting a session. So we have cookies. I'm just going to grab some cookies real quick. Then I'm going to post to the transaction API with the source coin of cash out, target coin of cash out with a balance of minus infinity. And then I'm going to post to join the club and print out the response. So if we run this, Python3, solve.py, we get the flag. It says Python can have float overflows too. So fun. The next web challenge is peak. Within the heart of Austria's alpine mystery lies your next conquest. Ascend the highest peak, shrouded in the whisper of past explorers, to uncover the flag.txt awaiting atop. Beware the silent guards that stand sentinel along the treacherous path, obstructing your ascent. And the author is Croexius. We're given a website and a download file. There were two parts to this challenge. First, we're going to be exploiting an XSS, and we have to bypass some CSP, and that'll give us the admin credentials or admin cookies. And then once we have admin cookies, there is some XML parsing that happens in an admin panel, and we can use that to exploit an XXE and read a file off of disk, which is the flag.txt. So the first part was that XSS. You can find this in this contact form. So we can say h1, hello, close h1, and we can see that if we look at it, so this is how you submit to the bot, which is going to open up a Chromium or a Puppeteer or something like that. If we take a look, we can see that hello is wrapped in h1, so we have content injection. If we look at the network tab, reload the page, we can see that there is a content security policy with script source self. So that means it only allows script source from this domain. There might be other ways to bypass the CSP, like they don't specify an object source or a base source. So there's probably a bunch of different ways. But we know that there's a very specific method called using polyglots, bypassing CSP using polyglot JPEGs, very well-known method. We know that's probably that one because there's a bunch of code for uploading images and validating images, so they're definitely hinting at this one, so I just did this one. So cool, so we can upload an image, and the way this polyglot CSP bypass, this polyglot CSP bypass works is it's possible to construct a JPEG image that is both a valid JPEG image and a valid JavaScript file. I'd recommend checking out the article. It's a pretty fun article. One little thing is we just need to specify this char set so that it works in all browsers. And yeah, we can just embed JavaScript into a JPEG and it renders by the browser. To do that, there's a bunch of scripts online for doing this. I found one, JS JPEG polyglot. You just run this little Python script, you give it a JPEG file, a JS file, and a polyglot file. So we can do that. Let's go to this. So here's my payload. One little thing, you have to start with an equal sign. Read the docs and it'll show you how everything works, but start with an equal sign, do document.location. We're going to do a webhook site, and we're just going to send the cookies. So to run the script, do Python3. It was called polyglot. First thing first, it wants a JPEG file. So we'll pass it sloppyjoepirates.jpg. It needs our payload file, the JS file, and then out.jpg. So we'll run this. If we take a look inside, we have this out.jpg. Looks like a pretty valid JPEG file, so cool. Then we're going to go back. We're going to do hi. We could try to figure out where the image is being uploaded, or we can just do this. Open, submit, view the message, and here's the image URL. So copy image address. So we have our payload at this URL. Then there's some code somewhere. What was it solved? We're going to put it here. So this is that payload. Also, you can find it in the GitHub or on that write-up. We're doing script charset ISO 88591, that script tag, and this should execute our payload. So let's open up a webhook.site. Hopefully this is the same one. Then we're going to go back. We're going to open up another support ticket. Hi, with our script payload this time. We're going to hit submit, and we wait. So it says message received and admin should visit. We just got a ping. There we go. So we have a PHP session now. We're going to take that, open this up. We're going to change our cookies. We're no longer a nobody. Refresh. Okay, now we're the admin. I'm not sure what that was about. So the second part of this challenge is now that we're an admin, there's this like edit map thing where you can place an icon. It accepts some XML. And so the trick with this is we're just going to use an XXC. So you can find a bunch of payloads and stuff. I just played with the payload for a while, and this is what I ended up getting. So this is an XXC, external entity injection. We're going to define an entity called test. And this test, when the XML parser encounters this, it is going to load the file from flag.txt and replace the text test entity with those contents. It still needs to be valid XML for this app. If you actually look at the code, it's going to do some replacing, and basically you still want it to be valid. So we're going to pass a valid latitude, longitude, and the name of this icon. Instead of it being Groblinglockner, it's going to be the flag. So we'll pass this, hit submit. Oh, actually, and there we go. GCTF, the mountain top has the best view. So fun little bugs. The next challenge is Where's the Scope? It says this year we are launching our new Glacier TV website, allowing you to play any video from YouTube. You can also take some notes while watching them and also restrict the access to those with a 2FA token. Hope you enjoy it. The author is XSS Kevin, given a website and a download file. So if you go to it, it plays Rick Astley. This is the URL of the YouTube it's going to play. You can click this button to set up 2FA, and if you do that, you can save notes without 2FA. So I'm saving a note. If you load note, it's not implemented, but basically there's an API in the backend for loading the notes. But if you have 2FA enabled, when you click load notes, you also need to pass in a valid TOTP token. You can view the source of it, and then you can also report for the admin bot. So if there's an admin bot, we know we have like an XSS or a CSRF or something. And that was the challenge. So there were two steps to this. First is, I guess, one or two steps. First is there is an XSS here. There's an admin bot, so there's probably, like I said, there's probably going to be an XSS. I'll show what that looks like, but basically you can close out of this. It's in some iframe source doc, and you can escape and run arbitrary code, send it to the admin bot, and execute JavaScript as that person, the admin bot. The admin bot has the flag, and what they're going to do is this. So this is the admin bot code on the server. They're going to set up 2FA, and then they're going to post the secret note, the flag, as a secret note. So stage 2 of this, we have an XSS, but we need to bypass this 2FA check. And so they call 2FA, they save the secret note, and then they go to our URL. So somehow we need to like bypass this 2FA check. This is the part that doesn't really make sense to me. Whenever you generate a new TOTP token, it's going to do this OTP secret from hex, 32 random bytes of crypto from crypto. So it's, it's secure. And this is your token, and that gets, returned to you. If you click on it, you get that little QR code that you scan. So what's weird though is in this file, there's like this Babel patch. I think it's related to this. And for some reason, I think what's happening in this Babel patch that I don't really know what it's doing is for some reason the TOTP tokens, the initial token is always the same, or usually the same. So I don't really know why, but basically everyone's using the same TOTP token. Like this looks fine, but I guess when this gets converted by Babel or something, it's using the same token. Don't really know why, but I just noticed that the same token was being returned. So that's what we can do since everyone's using the same token. It's pretty easy to bypass this check. We just need to generate a valid token. I think the window's like 47 seconds or something like that, 43. I think that's what this period thing means. And yeah, that's it. So we're gonna do an XSS. We're going to embed a TOTP token. In our XSS, this is what the XSS payload is going to look like. We're going to have this token. We're going to fetch the secret note in the XSS for the admin bot. And we're going to ask for that secret note. Once we have the secret note, we're just going to post it to some webhook site, and we should get the flag. To put it all together, first we need to host some scripts for the XSS. This thing is annoying. We're going to use an ngrok, a little Python HTTP server here, so the two are connecting. So we have our payload at this URL. Cool. Then we're going to do, oh, I didn't talk about the XSS. The XSS is in client. Cool. So that load video is going to come from this video URI, and when it parses it, it's just going to make sure that the origin is youtube.com. If not, it's going to be a rickroll. But we can see it's not doing any validation or anything. So we can just escape the quote and then escape the iframe, and we should have a valid XSS. So if we want to see what this looks like, it just needs to be that domain, and then we can do like injection is equal to close quote, close the iframe, and then like hello. Let's see if this works. And we can see we have a hello here. So now we can start putting script tags and stuff like that. And yeah, it's an XSS. And then once we have a good XSS, we just click this report button. We need a valid TOTP token. Right now I'm using this old one. To do that, kind of just a little bit of guessing checking, but if you click the setup to 2FA, we take this, we get a response. This is our setup token. Let's copy this out. I wrote a file called genToken. I'm using the same library that the backend is using just to keep things simple, make sure everything works. We copy that out, we put it here. It does seem to change every once in a while. Again, I don't really know why. Cool, to run the exploit, first we need to generate that token. So we'll generate a token, we'll place that here. Then we just copy this URL that has our full payload. Oops. Copy that out, we'll put it here. And we hope for and then we send it to the admin bot. And then we hope for a webhook. And there we go. The admin bot ran the XSS and we got GCTF, be careful with JavaScript compilers. So a little confused how the Babel stuff worked, but still a fun challenge. The first pwn challenge is FunChannel. It says, good luck getting my secret password, hee hee. Note there's a lot of files in the current directory. The flag file has an arbitrary name. It is the only file that ends with a .text and consists of only numbers 0 through 9 and letters. Flag format is still GCTF and the author is 0. We're given a netcat port and a download file. So this challenge was basically a test to see if you can write assembly. If we take a look at the binary, it's very simple. It's just going to do some buffering. It's going to allocate a buffer for us using mmap. It's going to ask us for some shellcode. It's going to knit some setcomp, and that's going to execute our shellcode. So we get to write shellcode. And the challenge is pretty much bypassing the setcomp profile. There's a way to see the setcomp profile. You can use a tool called setcomp tools, dump, and it'll tell you what the setcomp policy is. And so we can see we're allowed to use read, getDents, and openat. And these are the only syscalls we have access to in our shellcode. We can also see we only get OX7C bytes too. So we have, maybe 100 bytes of shellcode, 120 something bytes of shellcode, and we can't use any of these. And the flag file exists somewhere on disk. So, like I said, we're just going to be writing shellcode. Based off of these, we can see getDents. This will return all the files in a directory. Openat is how we open, and we can open at relatives paths. So we can open the local directory, get all the files in that directory, and once we figure out which file is the flag file, we can read it. There's no way to send back the flag, so then we kind of have to do a blind leak, and we can do that with some timing. So we can say like, if the first character of the flag matches this, leave the process open, and we just wait a second to see if the process is still open. If it's not, exit immediately, and when we try to, communicate with the process, it'll fail because the process or the pipe, the socket is no longer open. And so then we just need to code that into assembly. Like it said, the flag is the only file that ends with .text. So we're going to do that getDents, and we're really just going to try to find in that directory listing which file ends in .text. And like I said, we have to do all of this blind. So really it's just a bunch of shellcode. And yeah, I'll just cover it real quickly. It's really not too bad. So I used shellcraft pwn tools, makes a lot of stuff really easy. First part of the shellcode is I'm going to push the current directory, then I'm going to do an open at, and so I'm going to say at the current working directory, open the directory period, just the current directory using the O directory flag. You find these through just Googling. Then I'm going to allocate a bunch of space on the stack, so subtract OX1000 bytes from RSP, then call the getDents syscall with RAX, which is going to have the start of the current directory. The response here, this is the buffer to use, just use the stack, and I think this means directory listing. I forget what this flag is. Cool, so at that point we have on the stack, the directory listings is like these structures, and there's going to be a bunch of other crap. Really, we're just looking for a string that ends in .text. And so what I'm going to do is I'm just going to go through, starting from the stack, and just increment down or increment up until I find .text. And so you can kind of see this. I'm moving the start of the buffer into RAX. I create a label called text finder. I increment RAX, and then I compare if the value at RAX is equal to this value, a dword pointer, so 4 bytes, because that is .text is 4 bytes. So I'm saying, is this value at the stack equal to .text? If it's not, increment up by 1 and check again. Not the most elegant code, but it works. Once we find it, there's another label called file start. We need to go back to the start of the file. Thankfully, in the directory entry, the file will start with a null byte. So we're just going to go back down. So right now we're at .text, and we need to go back to the start of the file. I don't really care what the file is called. I just need the start of the string of the file name. So we're going to go back down until we find a null byte. Once we have a null byte, we know where the start of the file is. Cool, so we're going to then use shellcraft again. We're going to open that file. You can write this yourself and do the syscalls. It's just, I think it's easier if you just do it like this. So at the current working directory, open that file name, and then read that file onto the stack, and you get OX 100 bytes. Cool, so now we have it. At this point, like I said, we have to do that blind kind of testing. We're not allowed to write back the response of the flag, and so we're going to use that timing attack. And so we're going to say, ignore this for a second. We're going to check the very first byte. And so we're going to say, if the byte at the first flag byte is equal to our guess, so for the very first byte, that should be a G, jump to good. And obviously, it's just going to do this over and over and over and over. And so the process is just going to hang, but it's going to be alive. And so because of that, if we're guessing G, the process is alive. Anything else, the process will die. Cool. So we're going to send that shellcode over. We're going to wait a second. Then we're going to try and receive if the pipe is broken. If the socket is closed, this will fail. Otherwise, we should get a timeout, which is good. And that means we were successful and we guessed the character of the flag. This little minor code, not too important. We're going to be doing this byte by byte. And so we just need to increment a byte for how many bytes of flag we know. And yeah, that's pretty much it. Eventually you get out this flag. We can start somewhere in the middle, like right here, and see what happens. Python 3. Solve.py. Cool. So it's going to, maybe we'll do let's go back 2. So it'll do A. It's very slow. We have to wait a second in between. So you can get a coffee break or something, but eventually we'll hit A's. So we hit an A and it worked. It says nice. And so we can see the next flag is A. For some reason, it wasn't doing this D correctly. I don't really know why. Maybe it was just lagging out, but you can guess this is a D. It says, wait, did you really rebuild LS? But fun challenge. The next challenge is Glacier Rating. It says, I love C++, no malloc and free, so I can't mess up my heap management right. And this is by Nanika. We're given a netcat port and a download file. So it already tells us we're going to have a heap challenge, which is pretty fun. So let's close all this. If we run the challenge, it was called app. Welcome to your Glacier Rating, your secure and trusted source to rate the mountains. SJP, SJP. So we can do a bunch of different stuff. So we can create ratings, delete ratings, show ratings, scream into the mountains, and do admin stuff. Most likely do admin stuff will get us the flag, which it does. Scream into the mountains is probably something important, which we'll find out later. But basically you do this. You can say hi, 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 and then quit. And that's all it does. So it's supposed to be, you're screaming, nothing actually happens, but it becomes key later. And then, like I said, we can create ratings. So give me a rating, 5. Cool. And so we added a rating. We can only create a couple of ratings. You can see maximum amount of ratings reached, so we can only create 3 of them, something to keep in mind, but we can delete them as many times as we want, but sometimes the heap gets mad at us, so that's something else to think about. And then we can also show a rating, which can be useful for info leaks and stuff. Like I said, they said it was C, so they're not going to be using malloc and stuff, but you can still do heap management in C. You just use new instead and delete. So a couple of interesting things in the code. Like I said, they are doing deletes. So you can delete a rating at an index. So you could delete in the same pointer twice. We can see it's not going to clear out that rating. It's just going to delete whatever's at that rating spot. So we could get a double free, but this is using a modern version of libc. So we can't do that on the Tcache, but there's a way to bypass that. What else? In main.c, there was that scream, which seems kind of silly. Now scream to your heart's content. It takes in a line and lines. While the line is not equal to quit, it'll get that line and push it onto this vector, and then it does nothing with them, which seems kind of strange. And then there's that do admin stuff. You create a user, but if your user permissions are equal to admin, it'll give you the flag. Like I said, it's using a very modern version of libc. I think if you do libc, grep, you'll see that it's version 238, so the most modern version, I believe. So all the protections will be enabled. A couple of interesting protections that we need to bypass is there's safe linking on the Tcache. So they're going to do some XORing with the address space layout randomization. So we need a heap link depending on what type of attack we want to do. The Tcache also uses keys. And so when you do Tcache manipulation, it's going to look for a special key in there. I can show what these look like in a second. There's also, you need to be careful about double freeze. By default, it just doesn't like double freeze. So if you want to do a double free, you can't do it on the Tcache, but you can do it on a fast bin. You have to do like A, B, A if you want a double free on A. And that's pretty much it. The user structure is created on the heap, and we just need to flip that admin bit. So we need to do some heap trickery to flip the admin bit. I pretty much already kind of covered or hinted at the solution of everything we need to do, but kind of going through it, what we're going to do is first we're going to fill up the Tcache. We're not going to be doing exploits on the Tcache. We're going to be doing them on the fast bin. So we're going to create 3 ratings that we're going to delete later, but we don't want to delete them now because, like I said, we want them on the other bins. Then we're going to fill up the Tcache. To do that, we're going to use that stream structure. You need to look at the different sizes of stuff. Eventually, you find out that if you do 16, it'll be the correct heap size to fill up the Tcache bin that you want to have filled up. So we're going to send 16 A's 7 times to Scream. And so that way, when we free them, or when they're like they call delete on that vector object, they're all on the heap and the bin is full. Then we're going to delete rating 1 and 2. We're allowed to view ratings, so this will give us leaks. And specifically, we'll get a heap leak and a heap pointer leak. And so using those 2 things, we can calculate the address of the first heap address. They're using safe linking on the heap, so you just need to do some XORing. Basically, you just take the first 12 nibbles or 12 bits, you subtract that, and that is your heap key, I guess, which is just the address, and it's just XORed. It's called safe linking on the heap. Then we delete the first rating again. This is how we get our double free. And so now we have 2 heap chunks that are potentially pointing to the same thing. And so we can start doing some trickery with it. So we can create a heap object, modify it, and then when we free the next heap, since it's a linked list, we can have it point to some arbitrary location of where we want the next heap chunk to be. Cool. And from there, we're going to create a bunch of ratings. So we can create as many ratings. Oh, these will fail, so it won't be added to the linked list, but it'll still call malloc on them, and so it'll fill up the bins for us. So we're going to use all the ones in the Tcache, and so then we start using the fast bins. So then we're going to calculate the address of where the role is. The role is part of that user structure. You just look at where it is in the heap. We can see when we create that first rating, it's just 10 bytes above it. We need to do that safe linking. Like I said, this is the heap address, just another heap protection. From there, we're going to create a rating. So this is going to, since we're doing that double free, we have 2 different on the heap bins. 2 of them are pointing to the same chunk. So we're going to allocate a chunk. We're going to put an address in there, which is the address of our role. And then a bunch of filler bytes. Then we're going to allocate another heap chunk, which is just a normal heap chunk. And then we're going to go back to that first heap chunk, the one that's double pointing. When we create a new heap chunk here, it's going to, in the libc internal, say that the next heap address that you can allocate for, size OX24 or whatever, or 28, exists at this address. So then when we create the next heap chunk, it's going to give us a heap chunk that is in the user structure, specifically at the role address, and we're just going to assign a bunch of null bytes because that's what you need to bypass the admin check wherever it is. It just needs perms admin is null. Yeah, if you do all of that, then you're the admin and you can request the flag. I guess we'll put in one GDB just to kind of see what things look like and show some tools. Let's do a pwn.gdb.attach here. So after we fill up the TK, actually, let's do it down to, oops. After we delete some ratings just to see what the bins look like, let's do it locally. So we'll do Python 3, solve.py. So we're just going to look at the bins real quick. So there's a couple of useful tools. There's viz heap chunk, super useful. Usually I run it like this. So you can see everything that's on the heap, super useful. So we can see we have some fast bins here. We have a Tcache bin. Normally this will look up much better on your screen when it's not quite as big. Hopefully this is somewhat visible. So a couple protections that I mentioned, like I said, so on this Tcache bins, we can see this is the key. right here. So after you free it, so this is a free chunk. It has this key here, and the heap code is going to make sure that this key exists, which makes some heap manipulation pretty tricky. If it sees that this key exists, you can't double free it, which is why we're not doing exploitation on the Tcache bins. We can also see that this is pointing, so normally this is a linked list to the next free chunk. We can see that this is pointing to garbage, like 8692, and that's part of that smart linking heap protection. We need to XOR it with like these bits. So if we were to take this whole value and XOR it with this, then we get a valid address, and it's pointing to some other bin that's free. So viz heap, super useful. There's also the bins command. So this will show you where everything is. So we have Tcache bins. This is all the Tcache linked lists. When we did the screaming, this is what was being filled up. So this is pointing to this one, there's this one, there's this one, there's this one. Very useful. This is the fast bins. So these are our ratings that we're eventually going to do the double free. You can't free the same thing twice in a row, but you can free A, then free B, and then free A again. And because of that, then you'll have a double free on A. Yep, and to see the fast bins, this is what it looks like. We can see we don't have a special key here, so a little bit easier to do the double free, but we still have that smart link or whatever. So we still have to XOR it, but thankfully we get a link. If we look at the very first fast bin, we can see that its address is just this. So it is these bits right here. So it is just these. So you can just take the address, shift it right by 12 bits or 3 nibbles, and you place that value here because it's being XORed with null. And then for this one, this is this address XORed with this, gets you this. Yeah, anyways. Yeah, like I said, then next we would be doing a double free. Maybe I'll just put it here. Here's our double free. So we can see this bin is pointing to this bin, which is pointing to this bin, which is pointing to this. We can see it's like a weird color, but you can see that this chunk is the same as this chunk. So the heap is pointing to the same chunk twice, so we can free it twice, which should not be allowed. Another thing we forgot to do is, like I said, there's Sloppy Joe Pirates. So this is the user structure. This is the role, and this is our first free chunk. So basically, like I said, we're doing -10 to calculate the role. So we can calculate this address by leaking this value and this value. So we know this address. And then if we subtract 10, we know where the role is, which is this one. And right now it's 1,000, but we need to set it to 0. Yeah, otherwise, I think the rest hopefully makes sense. Like I said, we're going to create 8 ratings. This will go through. It'll clear all these so that we can then, the next 3 chunks we allocate will be the double free, ignore, and then the double free. And then the next chunk after that will be this one, after we set the correct address when we free this one, and we'll be admins. So we can run it on remote, see what it looks like. GDB, none. See if this works. Cool, and hopefully at this point we're admins, so we send a 5, and we were. Verified permissions, here's your flag. GCTF, I thought I could not mess anything up, so fun challenge. And that is all the challenges I was able to solve. So thanks to Los Fuzzies for hosting. It was a fun CTF, had no issues. The challenges were interesting and hard. Definitely had a good time. Like I said at the beginning of the video, I'm starting a new service. This is very experimental. I don't know if I'm going to continue it, just something I'm doing for fun. But I feel like there's a couple issues with CTF write-ups at the end of CTFs anyways that I don't like. The first one is I feel like I'm usually interested in most write-ups, but you have to like Control F through Discord to find all the write-ups for challenges you want. And it seems silly that we're all Control Fing through Discord to find these, and not everyone posts their write-ups to CTF time. So again, just experimenting. This is a service where at the end of a CTF, there will be a page like this. Again, it looks disgusting. I'll clean it up eventually if we continue it. But this was for the UpLive CTF, which was last week. It has all the challenges, the number of solves, a quick description, and here anyone can submit a write-up as long as you have an account. You submit it here, and it just should be a page with every challenge and write-ups that anyone can submit to. And as part of it, people can upvote write-ups they like, either here or on the homepage. And the top 5 write-ups for that week will be sent out in a weekly email digest. So if you just want to see write-ups for maybe CTFs you didn't solve, like the top write-ups, you subscribe, and every week they'll be sent out based off of community vote. So I'll make one for this CTF. I'll put it in the description if you want to check it out. If you have any feedback, feel free to message me on Discord. I'm Conrad, or in the YouTube comments or Twitter or anywhere. Again, I'm just experimenting. I don't really know what I'm doing, but I just hate control Fing through Discord, and I wish there was a central place that had all the write-ups and like a quick description. I think the other thing too is I'm not always interested in every challenge. Like if I've seen the solution before, I don't want to have to read an entire write-up to figure that out. But I'm hoping that like maybe with these short descriptions, like, printf, info leak, and then buffer overflow to one gadget. I've done that a whole bunch of times, so, maybe I'm not too interested in doing that. But, custom X5 or 6502 shellcode injection, I mean, that sounds interesting. Like, I don't think I've ever done that before, and so I'm more interested in reading this write-up. Anyways, yeah, if you think it's interesting, let me know. Yeah, I'm just trying things out. I'm excited to see how it goes. Anyways, thanks for watching, and I'll see you at the next CTF. Cheers.